So tidy code tips. Once again, these are just kind of best practices, advice that we want you to follow, because it doesn't just make your code look pretty. More often than not, when you're writing code, you're writing it for other people, and other people includes your future self. So trust me when I say Lawrence from 6 months from now is really going to appreciate it if the code is readable and legible and it's clear on what it does. Even if right now you're like, well, this makes perfect sense in my head to me, and no one else is ever going to look at it. Writing code for other people is super important, and trust me, say people on your team will hate you if you write really bad code that no one else can read, or it's really painful to read. Um, and also, when you write good, clean code, it's actually very easier to figure out what the problem is and how to debug it if any situations do come up. That first supplement is extremely true. Whenever I start building something new, I spend way more time reading the code that's already there about what's been done than I do writing new code. More often than not, writing new code is actually really easy. It's just to make sure that when you write new code, it does what you want it to do, which is really easy, and two, that it doesn't break something else, which is really hard. And that's why we spend a lot of time reading other people's code and reading and testing code, is to make sure that less that it does what we want it to do, which is important, but because there sometimes somewhere else it can break other parts of the code stack that you're not touching, and that's when things get really messy. It also just kind of makes it seem more professional, right? Like once you get into the workforce, people write code a certain way. There are certain best practices you follow, right? In the same way that if you're a lawyer, every day you come to the office, you're expected to wear a suit or a tie or or professional wear, right? Same idea. There's just a certain level of professionalism. As you may be aware, software developers are very casual with the dress code, but that just means that there are other kind of norms and best practices to follow. The first one, indentation. Indentation, a really big pain point for me. And if I come over and you're walking me through your code, I'll always make you indent it correctly first, so that way I know what you're talking about, or rather where you're explaining it. A good rule of thumb for indentation: if you ever have an open curly brace, the next line should be indented in 99% of scenarios. Okay, so if you're writing something, you have an open curly brace, indent the next section. All right. Conversely, if you have a closed curly brace down here, unindent the next line. Okay, that's pretty much it. It may seem very trivial, but what it does is it actually makes it very clear where your scope is. And when we talk about the section on scopes, you'll see why it's super important to make sure that the curly braces are aligned. But for now, the good rule of thumb is if you have an open curly brace, the next line of code should be indented, and vice versa if you have a closed curly brace. JavaScript, one of the things you'll notice with anything I say about clean code tips, JavaScript will run if the code isn't properly indented, right? JavaScript recognizes white spaces like, great, that's garbage, and toss it out. So your code will run. It's not going to break. What I'm saying is it's just not good practice, and it makes it really hard for me and also for you to look at the code and figure out what's going on, or something isn't working to figure out which part of the code is really breaking. So indentation. And then secondly, variable naming. Variable naming is more of an art than a science, really. The hard parts, or rather like the firm parts of it, are in JavaScript. We use camel case, and I say in JavaScript because other languages have other conventions for naming variables. JavaScript, we use camel case, which means you can definitely chain together several words, like my favorite place, but the first word is always going to be lowercase, and then every word after that, you should capitalize the first letter. And that way, when someone reads it, it's very clear kind of where the word distinction is. Like my favorite place, right? The F and the P are capitalized. That's probably the only hard and fast convention in JavaScript with regards to variable naming. These next two are definitely kind of more soft skills. So if you're just doing some really quick calculation, like something like var x or var y or var z or var I, like that works. And once again, JavaScript won't break. But if you're going to be using a variable really in other parts of the code, try to use something that actually describes what that variable is. Because trust me, there's nothing more painful than you having a very long page of code and something that has like var a, var b, var c, var d, and you're just looking at like I don't know what these numbers are, and it's incredibly painful to keep track of them. Okay, using better naming conventions for your variables is something that will help you just be a better developer in the long run. Having said that, though, the exception to that rule is sometimes when you're doing a counter, so if you're going to for loop and you're iterating over the entire course of the loop, this is an example, I guess, of a variable that has a very limited use case, right? Like I'm only going to use it to in the context of iterating over this loop. So in this case, var I can probably work in that case, and I would say this is probably the only case in which you would probably do something like var I or var x. In this case, I stands for index, right? Because we're going through the indexes of the array. But that's probably the only scenario which like that narrow of a use case is usually we can get it using var a or var I or var x. But for most other cases, please use something that if I was to look at it, I can at least try to guess what that variable is. Okay. Any questions on naming or indentation? Yeah, or that question, or just like a hair? Danielle?
Are the slides on?
Yep.
Slack?
They're not on Slack, but if you go to LearnDot really quick, I'm just going to use the data. If you go to LearnDot, I'm going to go to
Slides
LearnDot.
seems slightly different. Is that because you said the slides combined?
No, sorry. Go to the LearnDot platform where you just at, and go to Clean Code Yet. And then if you go to Materials, there should be slides.
There's two. I'm not sure.
Down both of them. They're probably, but that's where you'll see the slides in the presentation I do. It will all be in LearnDot for you. Got downloaded. It may be slightly different because of the format for today's lecture, but like the core content will definitely be there. Like the names might be different, the schedule might be a little different, but. Okay, so any questions on variable naming or kind of basic code conventions? We have a few more that will come up as we do more lessons. Awesome. So like I said, not very super complicated, and something that you'll enforce as you do more just work. Okay, so then moving on to the next one. Types. Oh, okay. So now we're going to move into kind of proper, more rigorous kind of JavaScript or programming just concepts. Assuming this starts. Oh wait, this is wait, this is. Oh, there we go. Okay, types. So once again, this may be a little bit of a review for a lot of you, especially if you found JavaScript Jumpstart to be pretty straightforward. What is a type? A type is really just it's something that gives it's a value and it's something that gives it a certain set of properties and characteristics that differentiate it from other types. Really, at the end of the day, what types really does is types are there to make your life easier. It's supposed to give a certain value, certain properties that makes it really simple for you to use it in one way or another. JavaScript has a few basic types. It may seem like a lot at first, but as you start using more and more, it'll become more straightforward what they are. But just know that the way a computer looks at text or a thing that you write is very different than the way that a human looks at it, right? So in this case, in the example on the board there, we have my string, which we put as a string, right? We put it in quotes, and that tells JavaScript, hey, I have this value, and the type of it is a string. Below it, we have something called my num, which we put to the value 4, right? And in this case, there's no quotes around it, and it's number, so JavaScript recognizes that this is a number type, right? So to JavaScript, these two things are fundamentally different. To a normal person, they might see that and think, oh, it's a 4. But just know that types are meant to make our lives easier, but it also means we need to be very careful with it. So when we print out both my string and my num, we get 4. And to the naked human eye, they look like they're the same thing, but really they're not. Because when we try to do anything with it, right, if we try to use any of the characteristics or the special properties on that, then we'll very quickly see that, hey, when we add two strings together, they just kind of push it together, right, side by side, and we get 44. However, if it's a number and we try to do the plus sign, JavaScript is wanting to like, oh, you want to add two numbers together, we push those two together, and we actually get 8. So types, once again, have special properties, and the reason why we're going to be careful with which ones we use is just because when we use certain types, we're going to make assumptions about certain properties that it has, And if those properties are wrong, or if those types are wrong, then we're going to get unexpected results. Okay, types in JavaScript. Depending on how granular we want to go, at a high level, there's two types. There's primitives, and there's objects, which are also called non-primitives, as the name is probably pretty clear. At a high level, who knows the difference, or who can try to guess the difference between primitives and non-primitives, or primitives and objects?
Objects contain primitives.
Objects contain primitives. Yes, objects can contain primitives, but objects can also contain other objects. So I can very easily have a nested array here, right, as one of the first elements. And so objects are definitely more flexible. They contain whatever, but they don't always have to contain only primitives. Anyone else? Fancy a guess as the difference between primitives and objects, or primitives and non-primitives?
It just seemed to me going through everything, maybe it's what you just said, but the primitives are more like the basic building blocks, the kind of foundations of what we're working with, and then the objects are things that contain more sets of things, nested things, groups of things, I guess.
Yeah. Yeah, so definitely, like from a high level, we think of primitives as like the basic building blocks, and objects are usually built on top of them. But from a purely programming standpoint, the difference between a primitive and a non-primitive is that we can change non-primitives. We can't change primitives, and so you'll see this a lot more as we go through some of the other problems. But in JavaScript, false is always going to be false, right? 2 is always going to be 2. Strings, which is the one that trips a lot of people up, strings can never be changed. What you can do is you can create a new string, but you can never change the existing string. Just like how you can't change a number, right? In JavaScript, if I try to write like 4 equals 6, JavaScript's going to yell at me and say stop it, right? Similarly, if I try to change any of these things, the JavaScript's not going to like it. Objects, I can change my heart's content, right? If I have an object here and it has a property key and a value, I can add more keys, more values, as many as I want until I'm satisfied. Same thing with arrays. I have 3 elements. If I want to add a 4th one, go ahead. JavaScript's happy to let me do that, right? With all of these things, I can change it. With primitives, I can't. And that's something that, don't worry about necessarily wrapping my mind around it, the entire thing just for now. But just know that this is something that's very, very key to understanding JavaScript types, is primitives versus non-primitives, or primitives versus objects. You can change primitives. You cannot change primitives. You can change objects.
When you say that, you just mean the mere fact of whether the variable or whatever is a number, or whether it's a boolean, as opposed, because I was also thinking with constants. Like when we use constants, we cannot change those, but if we use a variable, then we can change.
Constants is a variable type. It's not like a data type, so it's a little bit of a different implementation. Constants are they're just separate altogether from data types. Because anything can be a constant. Right.
Any of those, a string.
Anything here can be a constant, so to speak, but not everything can be a primitive versus an object, and that's more to do with how JavaScript treats these things under the hood. Okay, so we'll start with the primitives because as Justin mentioned, typically we think of them as more of the foundational building blocks for JavaScript. Numbers, pretty straightforward, right? Numbers, we can use negatives, we can use decimals. JavaScript is smart enough that it can actually just kind of convert them for us on our behalf, right? If I do a minus in the 3, it'll say, okay, I'm going to assume you mean -3, right? Same thing with a decimal. In some other languages, you can be very explicit and say this is the decimal, this is a decimal, this is an integer, this is a negative number, or whatever. JavaScript, not so much. It's pretty straightforward. If it looks like a number, JavaScript will just treat it like a number. Yeah. So obviously, what do we use numbers for? Well, we use it for math, right? Like really, that's the value of a number. That it's something we can count, we can add, we can supply, or we can multiply, we can divide. So similarly, everything here, all of these are very common arithmetic operators. If you have any problems with any of these, like let me know. But a lot of these are very straightforward. They're there's things that are universal across all the languages, including this guy, the modulo guy. Modulo just gives you a reminder. It tells you what the remainder is when you divide one number by another. And then does anyone know like why we use it in most cases? There's like a very common use case for it, but there are other common use cases. Anyone know why we use modulo in programming? One common use case for modulo in programming.
The exercises was like to try to determine between even and odd, but that was actually one problem. I didn't understand very well.
Yep.
But it was used to do something with that, determining whether the variable, the number we were working with was even or odd, whether it had a remainder or not.
Yeah, so determining something is even or odd is actually probably one of the most common uses for modulo. And the thought process there is, well, if I divide a number by 2, if I put any 2 numbers in this modulo function, what are my possible answers? Like what numbers could I possibly get no matter what 2 numbers I put in? 0, 1, right? And it's like, wow, like that's great. I can do this math thing and it'll either give me a true or a false, right? 0 is false, 1 is true, right? And so in that case, it's actually really good for determining whether something even or odd, because even or odd is only 2 possible answers. Modulo, I have quote unquote 2 possible answers now. I kind of map from one to the other. And so we'll do a few sample problems where that's like, where you'll see how that's implemented kind of in real life, if you will. But just know that like that's a common use case for modulo. Okay. Immutability and shorthands. Okay, and so now immutability is just like, as the word indicates, it means cannot change. And now we're starting to talk more about, hey, why is a number a primitive? Or rather, what about a number? Rather, what should we know about numbers and the fact that it is a primitive? How should that impact how we use it? Okay. So, var num, right? In line 1, we're creating this random variable called num. It could be anything. It could be, we don't know what it is yet. And then we assign the value of 12. So, okay, great. Num is now a number, right? 12. Num divided by 2, right? Line 3. This does nothing, because 12 is always going to be 12. We're not going to go into JavaScript and say, hey, by the way, can you change 12 into a 4, or into a 2, or into a 6, or any other number? Because somewhere else, someone can say, well, var foobar equals 12. Guess what? 12 is 12. It's a static value, and it's a value that cannot be changed. Okay? However, let's go through the bullets first on all of this. And this is true for all primitives in JavaScript. We cannot change anything that's a primitive, right? So if you ever see something that is a primitive value and someone says it equals to something else, it's just wrong. Or rather, it will, in best case scenario, it will do nothing. In worst case, or maybe vice versa, at some point it will either do nothing or JavaScript will tell you stop it. It will throw an error at you. Okay? However, when we look at something like line 5 or line 6, we think, well, hey, that's changing num, right? And the short answer is not really, because line 5 and line 6 are things I think you've seen in JavaScript Jumpstart. And what they're doing is actually a little bit more opaque. So one thing that you'll also know is the best way to learn ever is to just do it. And so a lot of times if you ask me a question, like rather than trying to give you like the verbal answer for it, I'll just go to something called REPL, which was what I use. It's like an online code editor. It's pretty flexible and fairly easy to use. And we'll just do an example in real life, right? So we'll see how it's done. So if I do something like, like var num equals 12, right? I do num equals 12, or sorry, num divided by 2. Well, sorry, this is printing it out. But if I console log out num, you'll see that num is still 12.
But it said undefined.
Undefined is what the function is returning. So what that means is okay. So really quickly, and this is something that like we'll talk a lot more about too. Console log is your best friend because console log helps you see what certain things are at points in the code. Console log is also only used for humans. It's so we can see the code. A computer treats console log as nothing, right? So just because something is console logged out doesn't necessarily mean the computer is going to do something with it. It just means, hey, this is what it is, right? We're not running anything. We're just looking at what the value is at the moment. Okay. What this green arrow does is it's what's being returned. And so in this case, if you look at our code, we're actually not returning anything, right? We don't see the word return followed by anything else in our code. And so JavaScript by default, every single function we run has to return something. And if you don't tell it what to return, it will always return undefined. And so that's why we see this undefined here, because we're not returning anything in our code. There's no return. But I also think REPL is kind of, I think, icky in that, like, if I do this, okay, yeah. Yeah, whatever. REPL is kind of icky in that, like, if we call something without a function, then this return is always going to be undefined. Right? So right now there's no function here. It's just we're just going through line 1, line 2, line 4, and then we stop. So in REPL's eyes, like, okay, like, you know, let's do line 1, let's do line 2. Oh, okay, in line 4, let's print out what num is at this point. And then lastly, we're not returning anything, so we return undefined. However, I think if I just put 12 here, okay, then it will implicitly return that. Not the focus of this particular lesson, but really what I want to draw your attention to is just the fact that I have this num, which is 12. I say num divided by 2, which should be 6, right? But when I print out num again, it's still 12. Like, that's the lesson here, is that, like, 12 is never going to change. However, in the code example, one thing we saw was something like, you know, what if we do num plus or equal like 1, right? Now when we console log out num, we get 13. And like, well, in this case, aren't we changing num? Not exactly, because what num plus or equal 1 is, it's actually shorthand, right? It's actually like just to make your life a little bit easier. But what it actually does behind the scenes is it actually stands for num equals num plus 1, right? So we're not changing num. We're not like modifying num. It's just like, oh, let's do this and do this. We're actually reassigning num. This equal sign here, that's a reassignment operator. And that's the only way you can change something, which is quote unquote, or which has been assigned a value of a primitive, is that you can actually say, hey, you're now no longer equal to this primitive. You're now equal to something else entirely different, right? Same thing when we do here and we do something like num plus plus. This is also shorthand, in this case, very explicitly for num plus 1. Okay, so in both of these cases, we don't see the equal sign as clearly, but just know that like that's what's happening. And so then, and so then when we come off here, when we come back to the slide here, that equal sign that I showed you, that's where the reassignment is. And then that's why coming down here, this changes num because it reassigns it. This changes num because it reassigns it. This doesn't change num because it's not reassigning anything, and we can't just edit something that's a primitive.
So you have to modify it and reassign it. You do not reassign it. You do not change it. That's
Right.
What you're saying.
Right. Yeah. It's almost like you have a variable name and you have the underlying value. You can point this variable name to something else, but you can't change its value to anything else ever. Next primitive data type, booleans. Probably in some ways the easiest one. There's only 2 possible values, true or false, very handy. That also means that the words true and the words false in JavaScript are reserved words, which means don't try to use them for anything else. You can say var false equals whatever, like I want a variable called false. Well, you can't. JavaScript says no, right? In fact, most of the things that you'll see in terms of like basic JavaScript are reserved words. Right? Like the word var is a reserved word. The word for is a reserved word. Just means you can't use it for your own variable naming. And once again, Boolean has 2 possible values. No. No is interesting. No basically means that. I should say this. No means that there's it could be a value, but there's not a value. Like it's not a value that we're evaluating right now. And that sounds confusing is because it is. And the reason why I'm presenting such a confusing way is because there is a difference between what's considered null and what's considered undefined, right? Those two are not necessarily interchangeable things. But what I will say for now at least is usually what null indicates is the absence of a value, right? If I want to know like what like how many if I want like I think of something think of a good example right now. But really like what null is it is a I'm not sure they use that placeholder. Null really is generally used as a placeholder to tell rest of code, hey, this is not a real value, or there's no value here. Undefined, on the other hand, is what happens when we haven't reached a value yet. As in like, oh, we don't know if it's null or not. We just know that there's nothing here right now. And so in the use cases, we'll come across a little bit. But for now, just in your mind, just when you think of null, just think of it's a negative value, or it's a value that indicates there's nothing here.
It's a negative value?
Sorry, like think of it like a void, like a black hole. Like that's what it is right now. Chris?
When we create a var, do we always have to assign something?
No, you don't.
So why would we use null if we could just write a var?
Yeah, totally. Yeah. So if I do something like like var, let's see, I'll call it var x, and I'll do console.log x. X is going to give me undefined, right? Because the idea is like, oh, I've not defined anything for x yet. Okay.
But is the reason why we would use null is just
Yep. So with null, like I'm trying to think of a good example for null, right? Like well, I mean this is kind of a sad example, but let's say I'm Facebook and you try to access your profile, right? And then you're like, hey David, show me all my friends and messages. And what I want to do is like, hey Chris, you have no friends and no messages. But I don't want you to think that like our server broke. It's like you have no friends and no messages. So in that case, I might give you back a null response to show you that hey, there is like it's kind of like your request was processed and the answer is nothing. So like so null is very intentional, and when you see it, it means someone put it there. Whereas undefined is usually something that's generated by JavaScript kind of almost automatically, right? In this case, if you define a variable, JavaScript is not going to tell you it's null, because null indicates that, oh, we tried looking for it, and there was nothing there, or the value is not valid, right? Instead, it's undefined, which means like we don't know what it is yet. So null, it's like a negative in the sense that it's not like a positive value, it's not a truthy value, it's a false value, but it's also very intentional. It's one of those things that like it's hard to explain just like with like in terms of like just very one line code. What you'll see in a lot is like let's say HTTP responses, right? Like I ask a server for something and it'll give me back a null response, right? That tells me two things. One is the server got my response and they processed it, and two, they gave me something that was null, which means that like they actually did the work to give me back a null. So yeah, it's like they did their best to get something from me. It just wasn't what I wanted. Oh god. Okay, I'm just gonna close it out of this.
Are we gonna talk more about the null thing? Because I really still didn't feel very clear. Because in the jumpstart, I didn't come across it very much.
Yeah.
We discussed if there wasn't any problems integrated.
Yeah, we'll come across null probably more. And null is something that like null happens a lot more when you're having one function pass values to another function. It's not something that's really useful when you're just executing like single lines of code, kind of consecutively. But null is something that you'll see a lot more when we talk about kind of callback functions and passing things back and forth between functions. Okay, so then on the other hand, undefined is kind of like it's mirror in that sense. It says like something's been declared, but we just haven't given it the right value yet. And so undefined is also what we call kind of not positive, or I say negative not in the numerical sense, but in the sense of like in a Boolean you have like true values and you have false values, right? Undefined and null are both considered kind of false values, or in JavaScript it's called falsy, like false-like values. So undefined. So whenever you see an undefined, it just means someone created something, but they haven't bothered assigning it a value yet. If you see a null, it means someone actually assigned it value of null. And then lastly, the last primitive data type is strings. Strings are people have trouble thinking about strings as primitive because they're like, well, why can't I just add a letter here, take away a letter there, etc., etc. It's just because of the way JavaScript implements implementation of strings makes or deems it a primitive. Although there are a lot of things you can do with JavaScript, or sorry, with strings and JavaScript that makes it feel like it's an array, even though it's not, because you can change an array, you can't change a string. You create a string by putting either single quotes or double quotes around it. There's not really any functional difference, except if you do have something in your text that actually uses a single quote or a double quote, you probably just want to use the other types of quotes on the outermost, right? So in this case, on the second one, JavaScript says, okay, great, you want to create a string with double quotes. I'm not going to stop thinking this is a string until I see the next set of double quotes, which is why in this case I can put a single quote here in the middle, and JavaScript knows that it's a string. Whereas if I use single quotes here, JavaScript will say, oh, great, you're going to say, oh, and that's the end of your string, right? So that's why that's the only kind of distinguishing part between single quotes and double quotes in JavaScript. And then what are the things you can do with strings? Well, you can do things that look like math, but really it's not, right? It's something called concatenation. So when you use the addition symbol or the add symbol, what it does is rather it's not obviously doing anything numerical because there's no numbers here. It actually just kind of pushes everything that you're trying to add together as a string into a string, right? So in this case, we say first name plus empty space plus last name, and we get A.B. Smith, right? So rather than adding them together, which I guess we kind of are, you're just kind of shoving them together into one really long string. And then here's the part where that strings can sometimes operate a little bit more like arrays too. Yeah, so basically, if I have a string here, we can add kind of like an array. We can just say, give me the fifth letter or give me the first letter. We access it with this bracket notation. We use the open and close square brackets, and we pass it to a number. And the number is the index of the string, right? Or which element in the string it is, or which letter in the string it is, going from left to right. Just like arrays, strings start off indexed at 0. So the first letter is index 0, second letter is index 1, etc., etc. Which also means that the highest index that you can possibly have when you access a string is going to be the length of the string minus 1, right? Because everything's shifted 1 to the left. And then lastly, for strings, just know that strings are, once again, we use strings because it's a data type of JavaScript that has a lot of really cool tools. And here are some more of the cool tools that we can use. I'm not going to go through these, or actually, I'll just go talk through them really quick. During your workshops, you'll need to use some of these. So at that point, I would definitely kind of come back and just look at this list to figure out which one suits your use cases. But the one thing I will say with all of these, just to be really careful about, is realize what it gives back to you, right? Returns. Not every single function is going to give you back the same thing, right? Some strings or some functions are going to give you back a number. Some are going to give you back another string. Some are not going to give you back anything. So when you use these methods, just make sure that you keep a very close eye on, hey, if I call this method, what am I actually getting back? Yeah, Justin.
Really briefly, what is substring as opposed to slice? I don't think I ran into that.
Why is what?
What is substring really quickly? And how's it different from slice?
Great question. So another thing of not necessarily needing to memorize this, but if I just search JavaScript slice and I search JavaScript substring, what we can do is we can actually go to the Mozilla Developer Network, and these are guys whose I think their job is to just write documentation for what it is. Okay, cool. So if we look at the syntax here, so this is documentation, right? This is the guys who write JavaScript. This is what they're telling you substring or slice is. At a very high level, it looks like one difference off the bat is substring. Substring requires at least one argument, which is where I start cutting it from, and then the second thing is it tells me where I want it to stop. So if I say I want like the fifth letter, and if I want all the letters from the fifth letter to the ninth letter, for example, substring is really really great. However, if I was to use slice, slice is actually both arguments are optional because if I don't pass anything, I think it gives me a copy of the entire thing. But what it does is I think zero base index and negative. Oh, and then I guess with slice you can also count from the back. You can do a negative number two. And then this and zero. And then I think lastly is whenever index you give at the very end, it takes I guess up to it, but not quite before it. I guess like the short version of this is that like for your use cases in most cases you probably use either slice or substring. But the reason why I'm making an example with just reading documentation is always read documentation about what you're using, right? Like it's something that even the most experienced programmers I know like still do. Like the fact that like there's all these little caveats and nuances to slice. I guarantee you, a lot of developers might know what slice does, and they might have a way of using it, but they probably won't know all these different like, small nitpicky rules until something breaks, right? And it's just because for a lot of programming, it's less about what do I memorize, but more like, hey, this is not working. Let me just check the source, or let me read the source code or read the documentation to figure out how I'm supposed to use it. So there might be certain use cases where slice and substring works differently, but if you're having doubts about what you're using, this is a place to go and figure out how it's used. And more importantly than like which one do I use, it's more like does this solve my problem, right? And if either slice or substring solves your problem, use the one that you feel more comfortable with. Okay, cool. All right, so string. Okay, and then if you ever get confused, you're like, hey, this thing I don't know what it is. Type of. Type of is really great because it tells you what primitives are. With objects, it's less, or sorry, with non-primitives, it's a lot less useful because it tells you everything is an object. So there is a problem here about trying to figure out how do I really determine what is an array versus not an array, and I'll leave it up to you to kind of figure out if there's any kind of really cool, maybe shorthanded ways to do that. But type of operators are really really good for determining primitive types. The only weird thing, and this is a JavaScript bug, that type of null is an object, even though it's technically a null primitive type. What happened here was, I think this was a bug in an earlier release of JavaScript, but then people just started making assumptions and started using it, and they really couldn't fix it afterwards because then it would break everyone else's historical code. And so they're just like, oh, let's just run with it and just call it this for now. So this is the only kind of like really weird thing that you should be careful about, but. And also, like, this is probably not the best example because you look at it, you're like, oh, wow, clearly that's a string with C quotes. Clearly that's a number, right? But where it's really useful for is even a variable. You're like, hey, var x equals whatever. And then 40 lines down, you're like, I think x is still a string unless I reassign it to a number. I guess what is it? Type of x. That's where this comes really in handy. Like, this looks kind of silly because you just visually tell what those are, but we have variables there instead. It makes it a lot easier, and type of returns a string. So yeah.
Quick question, really not big deal, but why is the O capitalized? Because
Why is it what?
I made a mistake in the exercise type of when I tried to use it. Type of, like an index of, you have the O is capitalized.
So type of is a reserved operator. Index of is a function name.
Okay, so operators are you don't have to use the camel case.
Well, you don't define it is a thing. Like we define a function name. I can make a function called David's really cool function. Reserve words. Type of is a reserve word. It's not. You don't ever say type of equals this. Like type of is built into JavaScript as this. So they just want to make a distinction that there's no reason why you ever need to rename type of or anything. Yeah, Sarah.
Maybe I missed something, but is the question why is it
Yeah.
I can like why is it
Yeah.
why didn't the creators
Well, so I always thought because like when you camel case something, it's usually something that's like like you've written, like it's written as opposed to something that's built into JavaScript. So like, are any reserved words in JavaScript camel cased?
Index of.
It's not, but that's not a reserved word. That's an implementation of a function.
I think that's essentially all the things. It is different. Code is different. Like function is like a reserved.
Why is type of not camel case? Let's see if Google has a really good
Yeah, I
answer.
don't want to harp on it. It just I just remember it
Okay. Okay. Yeah, so camel case conventions typically camel case convention typically applies to functions and classes. Type of, instance of are not functions. They're reserved for words of JavaScript. So I guess it's like that's like usually it's something that like humans can like you and me can write or edit. We can make a camel case to show that this is like a human editable thing, whereas reserved words are just reserved words. And the really cool thing is, if you want, you can overwrite index of. Right? You can say like, oh, I want my own version of index of to be something else. You can overwrite kind of what the default version of index of is, but you can't do that with type of or with any reserved words. Yep.
When you create var as a primitive data type, do you always use var?
Do I always use var?
And also, question of what is the verb, right? Const.
Yep. Let and const are ES6 constructs, and what they do is they let you define scope. For now, use var. It's very versatile and it's really easy to use. When we talk about scope, I'll probably talk a little bit more about why we use let and const. Why sometimes we want to use let and const, why they're different, and why var may not always be the best solution. But for now, just use var.
For the most part, you say var means primitive type.
Var means any data type. Var is anything. It could be an object, can be anything. And really, like I think, yeah, in ES5, var is the only way to create any kind of variable. So everything is universally var. Having said that, let and const are also like using let, const, or var has nothing to do with whether or not the result is primitive or not. That's a completely different distinction. What let and var and const are, what they do is they really tell you where you can access this variable. Where in this code block can you access those variables? So it has nothing to do with primitives or non-primitives. Yeah. And for now, just use var. Okay, just class as a whole, just use var for now. It's just the safest way to go. We'll talk more about why var is bad later on.
That's bad.
Yeah. Well, I mean, yeah. Like, so if you ever see a code with var, it means it's probably ES5 because ES6 really doesn't let you use var anymore. But we'll talk about why that is. Okay. So changes in type. Once again, these are the ES5 JavaScript types. One thing to be careful about is sometimes when we talk about something called coercion, type coercion, right? It's because it happens we change one thing to another thing. So in this case, if we go back to our results, we have a num, which is a 4, we have a string, which is an 8, and we say, hey, let's add them together. Well, guess what? JavaScript actually won't break that because it'll say, well, I guess numbers have an add operator, right, to add numbers together. Strings have an add operator, which means I can shove 2 strings together into one super long string. So I guess I'll do my best to make this work. And so when we do my num plus my string, we get 48. Or rather, not 48. What do we get?
4 plus 8.
Yeah, we get the string 48. We get the string 48. Sorry, 48. We get the string 48, right? We don't get a number 48, and we know that because see, combined is 48. Well, that could be a string or a number. We know what it is. But when we look at type of, it's a string. Okay. Remember, my num never gets changed, and if they had console logged out my string down here as well, it would still be a string, right? So my num and my string don't get changed. What gets changed is we take their value, we actually treat them both like they're strings, and we store that new value under this combined variable. So just so you guys know, this is probably the biggest type of this is the biggest kind of gotcha in type coercion is this addition sign. Wherever you're trying to add a string and a number in together, it will convert it. It will convert both things to a string first, and then try to add them up as try to add both strings together. It's just something you need to be careful about when you start programming. Once again, like once you start using more and more, you get a better feel for it. But just know that this is expected behavior. And also know that this is actually also really bad code, right? Like if you were to write good, clean code, like even if you know this is going to work, even if you know, hey, eventually I want these to both be strings and I want to add together, you should still, or rather in practice, I've seen it happen. You still want to make this into a string first explicitly, because even though it doesn't do anything different, what it really does is show someone who's reading the code like, oh, hey, like I am very intentionally changing this number to a string and then adding it together. And then secondly is if something does break, if my num somehow, if someone changes the variable my num upstream to something else, we now have a very strict kind of way to check to make sure that it's a string first before we add it. And what that does is helps us avoid solid errors, right? So things that happen to my num that we don't know what happened. What I mean by that is so if I say var x equals 4, oh no, not that, var x equals 4, var y equals something like David. If I try to console log out x plus y, I get 4 David, right? Because it's going to try to take the 4 into a string first. What I'm saying is usually if you want to do this, one good practice I've seen is this is convert it first into a string. So that way I still get the same results, but now someone looking at this code knows right away that like, oh, I am intentionally making it into a string first. So it's very clear what I'm doing. And then secondly, if I change x to something, oh gosh.
Do you have any other choice other than to specify a string there? Could you do anything
yeah,
else?
totally. Well, yeah. So yes and no. Like if I did number here, it wouldn't.
Work.
Well, it wouldn't do anything different because it would convert to a number and then it would convert to a string afterwards because of this coercion. So this is just more like it makes it very clear to people like, hey, I'm doing this and I'm aware of it and it's intentional, and and if x changes somewhere up here where I'm not able to convert it into a string. So for example, this works, but if I was to do something like var equals function, let's see if this works or not. Okay, well, anywho, but obviously, like if we change x, something that's not kind of that we don't want to use anymore, then we can actually just like this is basically like another safeguard in place. For the coercions where it's not clear what we're doing, so this is a explicit coercion, right? I'm taking this x variable and I'm very clearly explicitly converting it into a string. However, if I took this away and I just did this, this is called an implicit conversion, right? Where we're basically saying, hey JavaScript, you do the heavy lifting here. I'll trust your judgment. In general, implicit coercions are more dangerous because once again, to the naked human eye, it's not usually extremely clear what's happening. Okay, yeah. So coercions, I'll come out here first. Coercions always need to be back a primitive. You'll never coerce something and get back an object. It's just JavaScript doesn't want you to do that. The other time that we see coercion really clearly is if we have something like an if statement or a while statement or actually not while statement. Or no, yeah, or a while loop. But primarily the if loop where we're expecting only a true or false back, right? If this is true or if this is false, that's the only thing that matters to us. Then JavaScript will also just take whatever's in that if statement here, and it'll just do its best to convert it into a Boolean. A Boolean is a primitive, so that works. And so that's why like sometimes when you see people write if statements, like you might see a statement that says like if my string. Well, what does that mean? How's that true? Well, we're gonna take a string, we're gonna try our very hardest to make it into a true or a false statement, and then based on that, what we're gonna do is we're then gonna execute the rest of the code. Okay. So these two forms of coercion, this one in my mind is fairly dangerous. This one is something that you'll get used to, and it's something that's actually somewhat clear because most people are very familiar with like, oh, when I have an if statement or a while loop, my goal really is to get this into a true or false state. Okay. And then lastly, the difference between implicit and explicit coercion. Implicit is, once again, we trust JavaScript to do our job for us. Explicit means we tell JavaScript exactly, or we make it very clear in JavaScript what's happening. Both before and after the operation. Okay, so any questions on coercion? Danielle? Oh,
Is there a longer string?
sorry?
You actually do the variable like x and then x2 string. Is that the long version of actually declaring it?
Sorry, x2 string?
X equals x, and then you do like the 2 string and parentheses that to give you like actually convert anything to a string.
I don't know if everything has a two-string function.
Yeah, we haven't talked about that. I know what you're talking about. It was like numbers
I'm
to
just,
strings.
yeah,
Yeah.
I'm just curious, is that like the long version? Is that why you're doing it another way?
So what you're saying is, let's say I have something like x equals 6, and then what you're saying is, should I do like x equals x dot toString?
Yeah.
I mean, that works too.
Okay.
Yeah, I mean, essentially, like, what all this is saying that, like, JavaScript's going to convert into a string for you, whether or not you tell it to. So you should tell it. You should make it clear, like, that's what's happening, and that this is not an unintentional side effect. Because the biggest fear with a lot of this is that like people might think, well, y is also a number, so then I'll be adding two numbers together, right? And the truth is that's not what you're doing at all. So that's why we just want to be really careful when we do any type of coercion to make sure like both like the reader and also the writer knows exactly what's happening here. Like I expect to get a number, I expect to get a string, I expect to convert the number into a string, and I expect to shove them together as if they were both strings. Sorry, did that answer your question? Maybe not.
So the string that string is that actually just label it, or does it actually act upon it and make it into a string? Can I use that as a shortcut to make anything in a string?
Oh yeah. Okay, I see what you're saying. So what you're saying is, so this now, so if I do, great. Okay, I think I just got your question. Sorry about that. So type of x. Okay, so right now, at first x is a number, right? And then x equals x dot toString makes it into a string, right? And your question is, oh, if I do something very similar where I do, like string x, I do type of x. Is your question like if this is now a string or number?
Right.
Yeah. So the answer is nope, because once again, x is a number. It's a primitive, right? We can't change it unless we reassign it. So here we're reassigning something, right? And we convert it into another primitive type, right? This does nothing because this would give you back something you can maybe use temporarily if you really want to, if you want to use it for reassignment. But it fundamentally does not change x because we can't change x because x is a primitive. Similarly, if I do this, if I don't do the reassignment, I ask to x dot toString, I try x, it will still be a number because once again, there's no reassignment, and so reassignment is the only thing that can change things from one value to another value. In the example that we were using earlier, even though we're not reassigning, the reason why this works is because the reason why this works is because we're actually not changing x at all. We're just temporarily putting a new value here so we can add it to y, and that's it. So if I was to try to figure out what string, so console log out string x, and also console.log out x. Oh, sorry. Type of x. You'll see that x is still a number. Even though I converted it into a string to use in this console log here, x is not being fundamentally changed because x was never reassigned. Yeah. And then Justin had a question too.
My question changed. So the difference between a bar line and a line where you're simply assigning like it's easier to recall. It's stored in stored in the connect space differently, or
Sorry, the difference between a var line and
and then like just one where you had x, where you just had the equal sign. So like, what would the difference be? So you have var x equals 6, and then like x equals 6. What are the difference between those two lines?
here.
Yeah.
Well, so var x equals 6 means I'm creating a new variable called x, and I'm assigning the value of 6. Line 2 says, hey, take that existing value of that existing variable x that I've already created, and let's give it a new value,
Okay.
right? So this is going to give you that. Believe it or not, this also works, and this is really, really, really bad. And we'll talk more about why this is when it's scope. So this is another example of something where it's like, hey, JavaScript will run, it won't break. It's doing a lot of really bad things under the hood that you don't know about until it's too late usually. So once again, this will run, but don't do this, and we'll talk about why when we talk about scopes. Cool. Okay. Okay, so conversion rules are set by the same guys who define what JavaScript is. And once again, don't get too hung up trying to memorize, oh, if I add a number and a string, I get this. If I add a string and this, and I get this, right? All this is Googleable. And I think right now we're moving into a world in which like you really can't be a really, really great programmer, I mean, without resources, right? Without documentation, without access to all these reading materials. And so like don't spend too much of brain power on memorizing these things, because these things will always be accessible to you. So when you need to look it up, you can always go look it up, right? The more important thing is that you know what to look up. So if you're like, hey, I'm adding these two variables, I'm getting really janky solutions, you might not know like what happens when you add a number to a string, but you just Google JavaScript add number to a string, like I guarantee that'll be like the first hit that you get. So at least knowing where to look is more important almost than just memorizing all the answers. Especially because realize that like these things can change over time, right? Tomorrow, ES6 or ES7 or ES8, they might say, you know what, we want adding a number and string to give us a number instead. In which case, what you memorize is out of date, but if you know where to look, you'll just find the latest answer. A lot more valuable. Okay. Couple more things here. And the reason why I'm going a little bit fast through this is because hopefully a lot of this is reviewed, right? Like you've all seen arrays, you've all seen numbers, you've all seen strings. So normally I'll go a bit slower with the material, but for now, because this is kind of a tight review, except we're adding a few kind of fun tidbits here and there, it's going to seem a little bit probably faster than usual. Okay, so remember I said earlier about like if I use an if statement, I expect things to either be true or false. Those are the only two possible answers. There is no third option or middle ground or anything like that. Coercive Boolean basically is what that is, right? And when we talk about null and define, I said, hey, in JavaScript, when we talk about booleans, there's things that are true or true-like, and the things that are false or false-like. We call them truthy or falsy. And what that really does at the end of the day is it's like a shorthand. It makes it easier for us to tell you if something is true or false. Okay? Realize that truthy and falsy is kind of a measure of convenience, right? Because we can always say, hey, I want true to be this, I want false to be this, and I can just add a if this equals true, or if this equals 1, or if this equals whatever. I can list out all these conditions, but JavaScript already said, okay, in general, we think that these things are false-like, and these things are truth-like. And so we're just going to give you this parameter if you wish to use it, right? So if I pass something like a string into a if statement, JavaScript can say, okay, based on what I know of strings, I think this is truthy, or I think this is falsely, etc. So so a lot of this is once again done on JavaScript side. And so if we move on to the next slide. Okay, I think one slide later tells you what the truthy and falsy values are. Once again, don't get too hung up memorizing them, but just know that like that's what's happening is that we're taking something that's not true or false, and we're trying to convert it into a true or a false. The other thing to know when we use kind of shorthand operators is this exclamation mark. We call it a bang. in computer science. And what a bang does is bang just says opposite of that, the opposite boolean of that. So if I have something that's true and I bang, I put an exclamation mark in front of it, now it's a false. Or rather, now I have a false value I can use. A bang will always produce either a true or a false, right? Now, the really cool thing is down here, this two exclamation mark, right? Let's say I have this string that's, like did David pass, right? And it's a string. And that string in itself is not very useful. What I need to do, I need to make it into a boolean. I need to make it into a true. How do I do that? Or how do I find whether or not something is truthy or falsy? I'll do the opposite of the opposite of it, right? Exclamation mark anything will either give back a true or a false. That's the opposite of what the exclamation mark X will always give me a true or a false of the opposite of what X is. So an exclamation mark in front of that will always give me the true or a false of what X is. And so you'll see both bang and double bangs pretty often when we talk about converting things from something that's not a boolean to something that is a boolean. Triple bangs don't exist because that's the same. Like two of the bangs cancel each other out. But when you see this, just know that it's not a mistake, and there is a very valid use case for why we would want to use double bangs as opposed to single bangs. Also, reasoning through bangs can be very confusing too. So if you need to diagram it out or just sit still and think about it, like that's perfectly fine. Like eventually they become more instinctual, but like the logic behind it is actually kind of brain dumping if you think about it hard enough. Cool. And then so this is a slide. This tells you kind of in JavaScript land what are true values and what are truthy values and what are falsy values. The good news is it's pretty straightforward. It's like falsy are these things, and everything else is truthy. So if you're not one of those, then you're going to be true. If you're one of those, then you're false. Does anyone know what this number 6 is down there? Not a number. Yep. What not a number is if I try to say, if I do like 7 multiplied by David, great, right? Strings don't really have the exclamation mark, or sorry, the asterisk, the multiplication operation, but numbers do. So JavaScript is gonna say, okay, great. So you want me to make this, and you want me to do some multiplication. Well, I can do it with 7. It's a number. I can't do it with a string. So the result you're getting back is something that's not a number. And the only other thing to remember here is if I do type of this, I get back a number because not a number is technically a number type in JavaScript. So that's just one more thing to be aware of. But if you think about it from a practical sense, it actually does make a little bit of sense, right? Like if I'm doing some mathematical operation and I get back an invalid result, well, it's probably not truthy. It's probably going to be false, right? So that's just kind of like why not a number is up there as well for number 6. So then we talk about like using something, like the short version is like, hey, there really should never be a reason for us to use equals 0 in any of our code anymore because, hey, we know that that's by definition truthy or falsy. It's falsy, right? So there's no point in having to check for equals 0. We're going to say if false, right? Or if double bang, then do this or then do something else. So these are just kind of shorthands. Like you're always free to write them out, the longer form for now while you're getting used to it. But when you see this kind of code in the wild, just know that this is why people have kind of done away with a lot of these conventions, or they moved away from one convention in favor of another convention, right? In this case, equals 0 just means is false. So great, let me just convert to a boolean and I'll just use that instead. Cool. So let's just do a few of these really quick. Does anyone? People can raise their hands for them, or I'll just call people at random because I need to practice your names too. All right, Becky, what's the first one? Bang bang 5. Okay. Oh, whoops, cannot do that. Okay, great. All right, so what do you think this is going to print out for us? What, Becky?
You threw it.
Why? Walk me through it.
Because 5 is a trophy value.
Okay, that gives me 5. So what should bang 5 give me?
Well, no. False.
It's either true or false. You have a half and half shot of getting it. False? Okay, great. So then what does bang 5 give me?
True.
Great. There you go. That's the first one. All right. Kaz, what's the second one? False. Oh, God. Is it false? Great. Everyone see that? 4 modulo 2. What does that give me? 0. And what's bang 0 going to give me? All right, 0 is false. So bang 0 is going to give me what? True. So then what's bang 0 going to give me? False. Great. All right. Undefined. Let's see who hasn't. Dennis. What's undefined? Or sorry, what's bang undefined? What's one bang of undefined? True? True. So then 2 bangs gonna give me false. Great. Then talk to Chris. False. Okay. So what's a dot length? Sorry. What value is gonna evaluate to? I'm sorry. 1. Okay. And then what's 1 minus 1? Okay. And what's bang of 0? What's bang of 0?
Oh, sorry, it would be false.
Bang of 0 is true, so bang of 0 is gonna give us false. Great. All right. Cash.
So false by itself would be true.
Okay.
And one thing would be
Wait, false by itself is true.
It's true that it's false.
Okay, so let's start with this. Is this true or false?
False.
False. I mean,
It could be true. Yes, is it true that it's false?
yeah. I mean, okay. So, so once again, there's 2 possible answers here. Okay, so you think bang true bang array of false is going to give us true or false? True. Okay. Cool. All right. So then, if we test this out, if I do console log of false, I get false. If I do bang of false, I get false. And if I do bang of false, we get true, right? And the reason for that is because an array is always true. No matter what value is in it, it's always true. I think even if the array is empty, I think it's still true. Yeah, it's still true. So, yeah, good rule of thumb. Objects, true. Okay, cool. And then lastly, the empty array is the last one that we talked about already. It's going to give you back also true because arrays inherently are just true. Okay, last set of slides for this.
Sorry. You
Yeah.
mentioned that arrays themselves are true. So if they have content that would read false, is it gonna reveal true anyway? Or-
Yeah, that's what the problem practice with, right? That one, the last one.
Yeah.
You have something that it doesn't matter if it's empty, it doesn't matter if false, it doesn't have negative values in it. It's always gonna be true because the array itself is true.
What if you're reading the value within the array?
Then it's dependent on what the value is.
Okay.
So if array index equals false, then that's
Array index.
yeah. So if you're trying to analyze
Oh yeah, sure, yeah. I mean, yeah, then you're just comparing like whatever is in the array, and you just do any of these operators. The point here is that like an object inherently is true, no matter what it is. Doesn't matter what's inside it. Doesn't matter what else is in it. The object itself is inherently true. Yep. So if I do, so if I do this, it's going to give me back a false. Yep. And I think same with an empty object too, right? Yeah. Empty objects are also truthy because objects are truthy in JavaScript. Contents do not matter. It's what you're on the outside that matters. Yeah. Okay, cool. And then lastly, this guy, or these two people, triple equal versus double equal. You'll see them in JavaScript a lot. What they mean is triple equal says, hey, only return true. So once again, whenever you use triple equals, you're always going to get one of two possible answers back. It's either equal or it's not. Okay? The way we determine whether or not it's equal is because the values are the same and they're the same type. Right? So is this? So just walk through this. True or false? True. This one. This one. This one. Right. As long as the types are not equal, it's an automatic false. Every time. No questions asked. Triple equal means to be equal, same type, and same value. Oh, God. Oh, okay. Double equal. Loose equality means, hey, let's try to convert you guys to the same type first, and then let's compare you, right? If you're equal, then we'll give you a truthy or a falsy value. So based on this, the first one, is that true or false? Great. Next one. False. Next one. Next. True or false? Okay, so you say false, Lawrence. Everyone else is true, and it's true, right? Because if I convert both of them to a string, it's truth, right? What about the second, the next one?
True.
True. True, and then the last one. True. Cool. Okay. Okay. Well, I'll just leave this up. Okay, so rule of thumb: never use double equals, like ever. And the reason why is because double equal. So I kind of very almost like trivially said, oh, they convert to the same data type and then the comparison, right? And you're like, okay, yeah, that makes sense. But what data type is actually being converted to? If I compare a string and a number, am I converting both to a number first and comparing, or am I converting both to a string first and comparing? I don't know the answer. Yeah, I don't either actually. If I'm comparing a string and a boolean, am I converting both to a boolean first, or am I converting both to a string first? That one I don't know either, but I'm going to go on limb and say they're probably going to convert to a string first. Maybe, maybe not. And that's why double equals is extremely dangerous. Is because we're letting JavaScript make a lot of assumptions for us that we don't actually know. Like it's not really like easy to know exactly what assumptions are being made on our behalf. And so, okay, all right. So this is the reason why the documentation guys at Mozilla gave you this really nifty, handy, easy to remember 6x6 diagram of what happens when you compare two things that are not of the same type. And honestly, like, please don't spend your night like memorizing this because this is not useful, and it's very dangerous. And really, when we're comparing things, like if you're trying to compare a number and a string, and you know one of them's always going to be a number, you know one of them's always going to be a string, and you want to convert it to something, just do what we did before, right? Make it a string explicitly, and then do a triple equals, right? If I'm comparing a boolean to a number, and I know for a fact that I want to compare them on their boolean basis, let me take the number, make it to a boolean first, and then do a triple equals, right? The reason why we don't want to use double equals is because this diagram is not very intuitive in a lot of ways, and it's super hard to remember. And depending on what the value, if the underlying value changes, this entire thing could mess up, whatever you're trying to evaluate. And so because of that, and because of programming in general, we always want to be as precise as we can. My word of advice to you is to always use triple equals. Don't rely on double equals because this coercion it's kind of janky and it's not fun to remember. And I almost guarantee you that if you do try to use it in some capacity, at some point in your life, it's going to do something unexpected, right? You'll be like, wow, this string is definitely true, and this boolean is definitely true. They must be true together. And Java's going to say, nope, false. All right, so this is why. So this chart does exist, and because of this, there is a use case for double equals. But for everything that we're doing in this class, and really, I think especially when you're starting off and learning programming, always do triple equals just to kind of really enforce that discipline and that rigor, so knowing exactly what everything is or what types everything is at a given moment. Okay, cool. So that was our review on types. Any questions?